In the name of God, my name is Soltani Nezhad, and my presentation is about a new method named TNT, which we have proposed for human action recognition in still image by using transfer learning. First of all, let's see what is action recognition. Human action recognition has become one of the most critical issues in machine vision and pattern recognition, and it divided in two main categories. First, video action recognition. Second, still image action recognition. The main challenge of still image action recognition are first, lack of temporal information that makes still image more challenging than video, and second of all, lack of dataset. That is one of the critical issues in still image action recognition. And over parameters network is one of the main problem in all machine vision's applications. So what is application of still image action recognition? The first application is image tagging, then web image retrieval, video frame reduction, and video-based action recognition, and thematic scene description, and human-computer interaction recognition is also another application for a still image action recognition. Early method of human action recognition relied more on manual features. Although these methods did not accurately classify human actions, they did not involve such computational cost. With the advent of deep convolutional neural network and the demonstration of their high ability to extract essential features for classification tasks, we have witnessed significant progress in various areas of machine vision. These methods, deep learning based action recognition, are divided into different categories. One of these categories is action recognition based on pose estimation. That has two problems. First of all is body part occlusion, as you see in the left picture, and another problem is different action have same human pose. Like, for example, in right picture, both girls has same pose but different action. One of them brushing her teeth and one of them blowing bubbles. The second method is action recognition based on image parts. That is definitely have problem with low accuracy in crowded background images. The third one that had better performance than other method is action recognition based on human object interaction, but it definitely need some additional image annotation like bounding box besides of input images. So our methods is based on transfer learning to solve, first of all, the lack of dataset in human action recognition, and second, didn't need to train over parameters networks. So the main architecture of TNT, the proposed method to transfer or not to transfer, has two parallel branches, a main branch and a sub-branch. The sub-branch contains an untrainable, fully convolutional network as a teacher, with pre-trained parameters on ImageNet dataset, one of the most popular and big dataset in computer vision. The main branch is a student branch and student network that is training for our main task, which is human action recognition, in order to better transfer knowledge from the teacher network to the student. The feature map of the last convolutional layer in the main branch should compare with the feature map of the sub-branch. To correct comparison, the feature map should have an equal number of channels. Therefore, we employ a regressor, as you see at the end of the network in sub-branch. So in addition to transferring useful content from teacher to student, the student network must also learn how to classify action from extracted features at the same time. Therefore, the loss function used to train the student network will consist of two parts. First, as you see, TNT loss, and second of all, classification loss or cross-entropy loss. To compare the teacher feature map with the student feature map, we can compare this feature map element by element. Doing this way increase the computational cost, especially when the output feature of both branch has a high dimension. Instead, in this article, to compare feature map more effectively, the gram matrix of this feature map is considered. The gram matrix is defined as first formula, which Fi and Fj are the vectors related to the dimension channel of Ij. Then the gram matrix related to the sub-branch at the main branch is compared with each other using the cosine similarity, and the TNT loss are defined as second formula, where GB, and GS are the gram matrix corresponding to the feature map of the student and the teacher. The third formula is the classification loss, which compared the output of classification layer with the label of the input image. At the end, fourth formula is the total loss of our proposed method and our proposed network, which is a linear combination of classification loss and TNT loss, where beta is coefficient loss, which is utilized to adjust the effect of TNT loss in total loss. At the end, we compared our method with other methods on action recognition in two main datasets in still image. First, Pascal-Vogt 2012, that as you see, our method outperforms and work better than previous methods by 91.7% mean average precision, and in Stanford 4D dataset is outperforms 2 by 90.4 mean average precision. So our method work effectively and outperform human action recognition in a still image by using transfer learning. Thank you for your attention.